Next one is the rectangle. Command is REC. Rectangle. Command is REC. Rectangle. Command is REC. Command rectangle. Command is REC. Command is REC. Simple thing. REC enter. Just write down the procedure. REC enter. REC enter. Select first corner point of the rectangle. Select first corner point of the rectangle. Select first corner point of the rectangle. Next, specify the other corner point. Next point, specify the other corner point. Specify the other corner point. Specify the other corner point. Specify the other corner point by two methods. Specify other corner point by two methods. Specify the other corner point by two methods. Other corner by two methods in bracket area or dimension. Area or dimension, two methods. Area, dimension, area or dimension. Now see here first. Simple thing. REC enter. Select the first corner point of the rectangle. You can specify the coordinate value, or otherwise directly you can dynamic selection. Directly you can select the point by using mouse. That is nothing but dynamic selection. Okay. Directly I am going to select the point in this location. Next, again I am going to specify the other corner point. Again you can specify the other corner point. Now this time also I am going to directly dynamic selection. Directly you can specify the point by using mouse. Again what happened here? Again this is a rectangle without dimension values. Without dimension values. Again you can design one rectangle, length equal to 10 and area equal to 120. Again next one more rectangle, width equal to 12 and area equal to 100. That one is the 100. Okay. Then again length and width. Now input mode, the input in the mode of area and length, input in the mode of area and length, again input in the mode of area and width, again input in the mode of dimensions. Okay, length and width. Now see here. Simple thing. REC enter. Select the first corner point. Okay. After selecting the first corner point, depend upon your input modes, you can select area or dimension and rotation also. Rotation means again you can design rectangle with some rotational angle. Okay, rotational angle. Now see here. First I am going to choose the area method. Now first I am going to specify the area of the rectangle. How much? 120. Area equal to 120. Enter. Then again what is the input? Length or width? Length. First one is the length. Select internal command as a length. How much length? 10. Directly you can design the rectangle. Okay. Next, REC enter. First corner point. Again you can select the area method. Area equal to 100 and width equal to how much? 12. One more. Okay. Next one. Input in the mode of length and width. Same thing. REC enter. First corner point. Then you can activate the. Just you can select the internal command as a dimension. Now length equal to 12 and width equal to 10. Now see here. Now this is our first corner point. Now with respect to first corner point, you can select the second corner point in first quadrant, second quadrant, third, fourth, any quadrants. Okay, any side. Just I am going to select in this location. That is about the area and dimension method. Next one, you can see the rotation also. Just now I am going to design one rectangle. Now this is the 20. Again this is the 15. Now this is the simple rectangle by using dimension method. Next I am going to design same thing in this format. Same, this one is the 20. This is the 15. And the angle with respect to horizontal is some 45 degrees. Angle with respect to horizontal is some 45 degrees. Okay. Now see here. REC enter. Select the first corner point. After selecting the first corner point, first you can specify the rotational angle. Rotational angle. Select the rotation. Our requirement is 45 degrees. Enter. Then again I am going to choose the dimension. Length equal to 20, width equal to 15. Same thing. First one, second, third, fourth, all quadrants as per the requirement. Okay, that's it. That is about the rectangle with the rotation angle. Just add up to this one first. Just separate one. REC enter. REC enter. Select first corner point. Select first corner point. Select first corner point. Next, select the second corner, other corner point. No, just not. Select the other corner point. Select the other corner points by using internal commands. Select the other corner points by using internal commands. What are the internal commands? Area, length, rotation. Sorry, dimension, rotation. Area, dimension, rotation. Okay. Select suitable internal command as per the requirement. Select suitable internal command as per the requirement. Specify the input values. Enter. Specify the input values. Enter. Okay. Specify the input values. Enter. Specify the input values. Enter. Okay. Okay. REC enter. What is the current properties? Current rectangle modes only rotation. Current rectangle mode is only rotation. Just you can select the point. What happened? The default one changes to 45 degrees. Okay. Again select the rotation. After completion of usage, again assign to 0, normal form. Okay, that's it. Then again you can see here REC enter. Again you can see the different internal commands. Chamfer, elevation, fillet, thickness, width option. Chamfer, elevation, fillet, thickness, width option. Different types of internal commands. Okay. Now see here, this is nothing but simple rectangle. Simple rectangle. REC enter. Simple rectangle. Again I am going to design rectangle with chamfer style. Just you can design rectangle with chamfer style. Again rectangle with elevation, rectangle with fillet, rectangle with thickness, and rectangle with width options. Okay. Now see here. First one is the rectangle with chamfer style. Chamfer style. REC enter. Select internal command as a chamfer. First specify the D1, D2. D1 is nothing but distance D1, distance D2. Again specify the first chamfer distance D1, 5. Again specify the second chamfer distance 5. You can specify any values. Enter. Okay. Now input is over. Then select the first corner point. Again you can select the second corner point by same 3 methods: area method, dimension method, rotation method. Just I am going to select the dimension. Length equal to 20, width equal to 80. Now see here. Rectangle with chamfer style. I can see one more time. REC enter. Again current, what are the current settings? Again chamfer mode is enable condition. Just you can directly select the point. What happened? The rectangle in the style of, in the format of chamfer. After completion of usage, again you can assign to 0. Again you can assign to 0. Chamfer changes to distance 0. again 0. Again select the first and second corner points. Now this is the simple rectangle. Now again REC enter. Select the interval command as a chamfer. This time I am going to specify 5, 6 different value. Okay, 5 and 9. 5, 9. This is the 9 value. Okay. Again select the first corner point. Okay. Next again you can choose area method, dimension method, any method. Just select the dimension. My input length equal to 45 and width equal to 35. Now see here. Now chamfer distance. One side is the 5, another side is the 9. That is about the chamfer. Just write down the procedure for chamfer. Then next one, fillet. Next one is the fillet. REC enter. Next one is the fillet. Fillet means convert sharp corner to round corners. Round means we can specify the input value in the format of radius. Okay. Now same thing. First you can select the internal command as a fillet. Specify the radius value. Now I am going to specify radius value equal to 5. First corner point. Again I am going to this time I am going to use the area method. Now my area equal to 150 and you can specify any one of length or width parameter. Now length changes to 10. 10 not possible. 15. Okay. Now see here. Again this is a rectangle with fillet. Again small values all are them. Again you can design one more one. Fillet value changes to 2. Again first one. Now select the area 150. Now this time length equal to 13 and width equal to 12. One parameter is enough. REC enter. Again the current mode is the fillet mode. Already enable condition. Directly select the first corner point. Specify the area. Area equal to 150. Then select the internal command length. Now length value changes to 30. Now see here. Now these are the what type of corners? Rounded corners. Okay, circular corners. Okay. That is about the rectangle with fillet. Then next one. Now we can see rectangle with first you can see the width option. Okay. Now what is the current mode? Current mode is the fillet. First after completion of the usage again assign to 0. Then again you can select internal command as a width. Specify the width value some 2. Select the first corner. Again you can select the second corner. Again this is nothing but width rectangle. Again REC enter. What is the current mode? Current mode is the width 1. Again change width to 1. First corner point. Next corner. Okay. That is about rectangle with width option. Then again you can see multiple operations. Now REC enter. My requirement is chamfer and width. First I am going to specify the chamfer 3. Okay. Again specify the width 1. Select the first corner. Again select the second corner. Again what happened? How many operations?
2 operations.
Rectangle with chamfer and width. Then again REC enter. Again fillet changes to 3 value. Again thickness changes to 1 value. Again first one. First corner point. Again select the second corner point. Again this is the rectangle with width and fillet. Now this is the chamfer. This is the fillet. Okay. Just write down up to this one. Now what is the current view? Top view. Again you have orthographic projections and isometric projections. Orthographic means 2D views. Isometric means 3D views. Total 6 2D views. Again 4 isometric views. Again 2D views nothing but top, bottom, left, front, back. All the 6. Again 3D classified into, depend upon the direction, classified into 4 types. Again this is the canvas representation of, this is nothing but canvas representation of view toolbar. Again this is the icon representation of the V toolbar, nothing but V cube. This is known as a V cube, canvas representation of V cube. Okay, now current view is the top view, current one is the top view. Again same thing will be present top view. Now I am going to design one rectangle with elevation, elevation. First, what is my current settings here? What is my current mode? Rectangle mode is fillet and width. First I am going to assign the values 0, again this one also 0. Then I am going to select internal command as a elevation, specify the elevation 100, select the first corner point, select the second corner point. Okay, now again see here, again I am going to design one more rectangle, RAC enter. Now this time I am going to specify elevation equal to 0. Again this is the first corner point and again this is the second corner point. Just I am going to change the view. Just I am going to change 2D to 3D view. Again what happened? Now just wait. For clarity purpose, apply the orbit over enter. Now see here. Now this grid structure is nothing but our plane representation. Now see here, x and y, xy plane. This is nothing but xy plane. Again what happened? Now this is the rectangle with elevation 0. Again this is the rectangle with elevation 100. That is the use of the elevation. Again just I am going to change us to top view. What happened? Same representation. In top view, same representation. Again for visibility, clarity purpose, you can change us to your view into 3D view. Again for more clarity purpose, just apply the orbit. Rotating purpose, just see here. Okay, elevation. Again this is the 0 elevation equal to 100. Again same thing you can represent in front view also. Now is the top view. Now again I am going to select the front view. Now see here. Now this red line represent plane line. Again see here, this is the above the plane, again this is the on the plane. Okay, then again changes to top view. Then next one, next rectangle with thickness, RAC enter, specify the thickness some 100 value. Okay, now first corner point, second corner point. The current view is the 2D view, that's why you can represent only 2D. Then again you can see the multiple operation. Now again you can see the multiple operation. RAC enter, select elevation as a 100. Then again thickness also 100. Okay, first corner point, second corner point. Again for clarity, visibility purpose, view purpose, changes to 3D view. Again you can see here two rectangles, orbit. Now see what happened. Now rectangle with thickness, elevation equal to 0. Again rectangle with thickness, or rectangle with elevation, rectangle with thickness and elevation. Okay, now see here. Now this is on the plane, this is the above the plane. Okay, just I don't know these two. First rectangle with elevation. Now just wait. Now see here. Again these are nothing but, this is the view toolbar, nothing but V cube. Now this is nothing but visual styles. By using these visual styles, you can represent 3D objects. You can represent different styles of representation of a 3D object. Now first one is the 2D wireframe. You can represent entire 3D design in the format of simple lines. Okay. Then just I am going to select the shaded with edges. Just wait. Okay. Now what happened this time? In the format of shadeds, 3D format. What happened? Directly shading format. Again changes to 2D wireframe, simple wireframe format. Okay. Now just wait for, I will explain again this one in 3D. Just write down. First one. Now helix. Next one is the helix. Command is the total name helix. Now see here, just I am going to select the helix. The helix contain bottom one circle, one cross section, top also cross section. Again both cross sections are circular cross section, both are the circular cross sections. Just select the helix. Helix, okay. Specify the, again what is the format, what is the base. Again this is the base of the circle, this is the top of the circle. Again what is the base shape here? Just circular cross section. Again this one also circular cross section. So for that purpose, first you can specify the base point. First you can specify the center point of the, first specify the center point of the base. Just I am going to select the center point in this location. Next specify the base radius of the helix. Base radius equal to some 50. Okay. Then again I am going to specify the top radius. Specify the top radius. Top radius also 50. Base also 50. Top also 50. Then you can specify the helix height. Then you can specify the helix height. Before going to specify the before specifying the helix height, first you can change the helix properties. First you can change the helix properties by using internal commands. Now first one is the axis endpoint. Next one is the turns. Next one is the turn height. Next one is the twist. Now I am going to select the turns. Now my requirement number of turns, the default number of turns equal to 3. The default number of turns equal to 3. Now my requirement is some 10 turns. Enter. Okay. Then I am going to specify the height of the helix. Now my height equal to 200. Height equal to 200. Just this is the top view. In top you can observe only circle. Again southwest isometric. Okay. Southwest for designing of springs. This is the very important. For springs design, comma and threads design, bolt thread design. Helix is important for mechanics. Okay. Then clarity purpose, orbit. Okay. That is about the, again see here, one more one. The next one same thing. Helix. Specify the center point. Now my base equal to 50, top also 50. Then I am going to choose the, now this time I don't know the turns. Now I know only total height and turn height. My input in the mode of total height and turn height. Now for that, now in this time select the internal command as a turn height. Now see, previous one is the number of turns equal to 10, total height equal to 200. So turn height equal to 20. Now this time I am going to change turn height equal to 30. Then I am going to change the total height. Total height changes to 250. My input is turn height equal to 30, total height equal to 250. So number of turns equal to how many? Number of turns 250 divided by 30. Number of turns equal to some 7 or 8, 9. Okay. Now top view. Now see here. For clarity purpose, apply the orbit. Okay. Then again you can check your turns. Helix, center point 50, 50. Now just activate the turns. What is my previous turns? 8.33. Okay. By using turn height and total height of the helix, by specifying turn height and total height of the helix, you can prepare decimals also. The decimal format of turns. Now by using turns option, just I am going to enter 8.45. That is not possible by using turn heights. Just for the entire thing depend upon the internal commands, depend upon the input value. Okay, just try that. helix center, helix center, helix center. Select center point of the base, select center point of the base, select center point of the base, select center point of the base. Next, select, just next, specify the base radius value, specify the base radius value, specify the base radius value. Next, specify the top radius value, specify the base radius value, enter, specify the base radius value, enter, specify the top radius value, enter. Next, next, specify the height of the helix, specify the height of the helix. Next, write a note. There is a common process. Next note, before specifying height of the helix, 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 first we can set helix, first we can set helix settings, helix settings by using internal commands. First we can set helix settings by using internal commands, by using internal commands. What are the internal commands? Just write down the internal commands. First one is the axis endpoint. First one is the axis endpoint. Axis endpoint. Next, turns. Next one is the turn height. Next one is the turn height. Next one is the twist. Next one is the twist. By using turns, you can specify the number of turns. Then you can specify the height of the helix. Next, turn height means first to specify the turn height. First to specify the base point of the helix, base radius, top radius. Then select internal command as a turn height. Specify the turn height value. Enter. Next, specify the total height of the helix. Enter. For visibility, for clarity purpose, again changes your view from top to 3D. Okay, that's it. Just add turns, turns internal command. By using turns internal command, by using turns internal command, we can specify the helix. We can specify the number of turns, number of turns of the helix. You can specify number of turns of the helix. For that purpose, select internal command as a turns. 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 Specify the number of turns. Specify the number of turns. Enter. Specify the number of turns. Enter. Next. Next. Specify the total height of the helix. Enter. Specify the total height of the helix. Enter. Okay, just write the next one. Next one is the turn height. Next one is the turn height. Turn height. Select internal command as a turn height. Select internal command as a turn height. Specify the turn height value. Specify the turn height value. Enter. Specify the turn height value. Enter. Next. Specify the total height of the helix. Enter. specify the total height of the helix, enter. That is about the turns and turn height. Now see here, just I am going to change this to 3D view. What happened? Every time you can prepare helix only in Z direction. The height always taking in, the height is always Z direction. Again you can change the direction also. Again you can change the direction also by using axis endpoint internal command. By using axis endpoint internal command. Now see here. Same helix center. Specify the center point 50, 50. Okay. Select internal command as a axis endpoint. Just I am going to specify the axis direction 0 degrees. Again you can specify your angular direction by setting polar and everything. Okay. Then again same thing. Now see here. Now axis endpoint. Just I am going to specify the direction first. First I am going to specify the direction. Then I am going to specify the length of the axis. Now axis length equal to 250. Okay. Then again changes to 3D. Now see here. For clarity purpose, apply the orbit. What is the direction currently? X direction. Okay. X with respect to 45 degrees, some degrees. Okay. Some angular direction. That is about that is the use of the axis endpoint. Just type axis endpoint. Select internal command as a axis endpoint. Select internal command as a axis endpoint. Specify the direction of the axis. Select internal command as a axis endpoint. Specify the direction of the axis first. Specify the direction of the axis first. Specify the direction of the axis. Then specify the length of the axis. Specify the length of the axis. Okay. Then next one. Again helix. Specify the center point of the base. Now I am going to specify base radius equal to 50 and also top radius also 50. What type of spring? Linear spring. Linear spring. Now see here. Now turn height changes to 20. Next one. Total height changes to 200. Now just changes the 3D. What type of spring? Linear spring. Why means top radius 50, bottom radius 50. Both are equal. Again I am going to design taper springs. Again you can design taper springs. For that purpose, same thing. Helix. Okay. Center point. Now my base equal to 100. Top radius equal to 50. Top radius equal to 50. Different values. Bottom equal to 100. Top equal to 50. Again you can change bottom 50, top 100. Any values. Then again turn height. Turn height changes to 10. And total height changes to 200. Now see here. Changes to southwest isomer. For visible clarity purpose. Orbit. What type of spring? Taper spring. Again this is the linear spring. This is the taper spring. Okay. Then again you have one more internal command. What is that one? Twist. Okay. Again by using helix you can prepare different types of threads. Again threads classified into two types for mechanical. Left hand threads and right hand threads. Left hand means counterclockwise direction. Right hand means clockwise direction. The thread direction is clockwise direction. Okay. Same thing. While designing helix, we can set the twist values. Center point of base 100, top also 100. Just I am going to select the twist changes to clockwise and counterclockwise. Just I am going to select the clockwise, enter. Again design one more one, same helix, same 100. This time twist changes to counterclockwise, enter. Again twist counterclockwise. Okay, just see here. Now these three. Okay, just apply the orbit. Now see here. Now what is the direction of the helix? What is the direction? Clockwise direction. Every time you can observe from bottom onwards. Every time you can observe base onwards. Again this is the direction of the helix. That is nothing but clockwise direction. Again this is the anti-clockwise direction. It is classified in two types, clockwise and counterclockwise. Clockwise means right hand thread preparation purpose. Counterclockwise means left hand thread preparation purpose. Okay, that's about the twist. Write down the twist. Select internal command as a twist. Set clockwise or counterclockwise. Set clockwise or counterclockwise. Select internal command as a twist. Select internal command as a twist. Set clockwise or counterclockwise as per the requirement. Clockwise means right hand threads. Counterclockwise means left hand threads. Okay. That is about the clockwise and counterclockwise. That is about the helix. Okay, just I am closing here. Tomorrow I will explain helix is over, donut over, spline, helix and spline, helix, block options. Okay, again point also, table is also. Okay, tomorrow and day after tomorrow I will complete the next two sets. Okay, again this one taking more classes, 5 classes. Again remaining thing, this one is the 2 classes, this is the 3 classes. Okay, just close.